Hello, welcome back to another episode of Let's Talk Climate Change. Today is a special pleasure. I have with me Professor Madhavan Rajeevan Nair, and he was a former Secretary of Ministry of Earth Sciences and is now the Vice Chancellor of Atria University. So welcome, Professor Rajeevan. It's a real pleasure to have you here.
Thank you very much. I also a pleasure to come here and talk to you.
Wonderful. So I'll start with a little bit of introduction for the audience about Professor Rajeevan's career. He has a PhD from Savitribai Phule University in Pune, and a long time ago he was doing a PhD in the physics of meteorology, which is a very interesting thing because I think you have now close to 40 years of experience working on meteorology and weather forecasting. And that is a unique history, especially in India, because the South Asian monsoon is so complex.
Yes.
You were one of the early people who set up our entire weather forecasting system, spatially downscaled it to a 12 kilometer by 12 kilometer grid, which is quite fascinating. You've worked, of course, extensively in science with more than 200 publications, and I think a very impressive publication record. Very interesting 2025 book, which I'll ask you to speak about on the challenges and complexities of forecasting the South Asian monsoon. But also you're a scientist who engaged with policy and have been secretary with the Ministry of Earth Sciences.
Yes.
And have now, once you retired, moved into science administration by becoming the Vice Chancellor of a new private university with ambitious plans on looking at science technology policy.
Yes.
So for us, I think it is a very unique trajectory. Many young people listening to this will be very interested in how this happened. So
that's true.
So I'll start with a very basic beginning. Where did you grow up?
I grew up in a small village in parts of Kanyakumari district. So parts of there's a southern parts of Tamil Nadu.
Okay.
But it's in the Kerala border. Kanyakumari district was part of Kerala before 1956.
Right.
And so after the state were divided, so Kanyakumari came to Tamil Nadu. So I was born in a small village called Minjira, a small village. So there I grew, and my school was very near to my house, but my college was very far. So I used to go by bus and walk, and so even school I used to walk about at least some 2-3 kilometers.
Was it a coastal village or
it's a coastal village? Coastal is not exactly on the coast, but it's a coastal village. For example, when you sleep in the night, you can hear the voice of the ocean, sea waves. Especially if because the village, night no sound, so you can literally see. So from there is hardly 5 kilometers is the coast.
Okay. And close to the forest also, I'm assuming?
The forest means some hilly region is there nearby, but there is one beautiful river flows through my village. So this is a beautiful place.
And it's still as beautiful?
Still it is beautiful.
Oh, wonderful.
Still it is beautiful. I visit often there.
Okay. And how far did you have to go to college?
College, it was about 5 kilometers. So I used to go by bus. I used to walk about 2 kilometers to go to a bus stop, and then from there pick up the bus. And go.
So would you say it's a childhood full of nature around?
Yes. Nature was very close to me, and I also enjoyed walking through the nature. I used to go for trekking, that kind of things. Go to a small hilly region and stay there for a few days, few hours, along with my friends. So I really enjoyed my childhood.
And then what made you move to physics? Because MSc and PhD was physics.
Yeah, BSc and MSc was physics. So when I finished my so-called pre-university class, so my brother did physics, BSc physics.
Okay, older brother.
So then I know many my seniors, so my cousins, etc., who are all doing physics. So I thought physics is a wonderful subject where you can do. And PUC also we had maths, physics, chemistry. So the physics was really, I was fascinated by physics. And so I opted for physics, even though I scored higher marks in maths. So I remember college principal was asking me, why can't you choose maths because you are too good in maths. So then I preferred physics.
But you never were interested in engineering?
I never tried. So engineering was not in my...
Pure science was...
not in book. And also my family was so not that good to send me for engineering course. So because I could study even MSc because it was in the same college where I studied BSc. So MSc program came in just 1 year after my BSc course. So I could join there. And if it was not there, probably I would not have studied MSc. So
serendipity, one of the things we have these conversations with people. It seems that there are tides in our life that if we take advantage of, people reach where they are.
Yes.
But were you interested?
I was lucky that I could complete. And also it's very interesting that out of 12 vacancies in that college of MSc course, I was from open category, So only one vacancy was there for open. I could get it in MSc because I was topper in BSc.
So you only one category, only one seat, and you got that open seat. Wonderful.
So I feel very fortunate that I could get
Absolutely.
it.
So when you did your BSc, MSc, which were the areas of physics you were interested in?
So I was more into the theoretical aspects. So I was good in maths. So I used to take a lot of interest in
Theoretical physics,
especially quantum mechanics. I was not good in experiments. So people say you need a lot of patience for doing an experiment lab.
I'm very bad at experiments. I
Yes.
don't like sitting in the lab.
I also. So I scored very poor marks. Of course, I did well in experiments also, laboratory experiments and all. There's marks for experiments, but I was not so good. But I was so good in theoretical exams. So I scored very good marks, quantum mechanics, mathematical physics. I used to score a lot.
And was weather anywhere on the horizon? Did you know about weather and climate?
Weather was not so. At that time, I see weather I used to watch because there is a region where you get monsoon. First monsoon spell gets in southern part of Kerala. So when my school is open first week of June, invariably we get wet. We go to school and come back, it will be wet. So I used to ask my mother, why it is whenever my school is reopened, this rain comes. I was not knowing about monsoon and all. She said it's called a place, it's a name called Idavappa. Idavappa means it's a Malayalam month, Idavappa. And Padi means mid. So it's a mid season of Idavappa, the monsoon rain starts. That's on 1st of June. I was not knowing about monsoon till I studied college. So rain was, and whenever you go in the evening for playing, if rain comes, I am really perturbed. So I will not be able to play, So that kind of relationship I had. But I used to look at the clouds and that kind. So weather was a little fascinating to me.
But no farm.
I never thought I will become a weather scientist.
Was anybody around you doing farming? And you had
my father was a farmer.
Your father. So through that also you would have some
my father was a farmer basically. He was an advocate's clerk, but then he also used to do a lot of farming, and we had small land, coconut trees and all. So my father used to work a lot with the digging and all these things. I never used to help him, but then I used to see that what he's doing it. So farming is a part. It's a small village and you have a lot of trees around, a lot of paddy fields. It's a beautiful place.
And then how did you move to Savitribai Phule University?
That is a story. So after MSc, what did I really wanted to do a PhD? So then I joined TFR, Tata Institute of Fundamental Research, immediately Bombay, immediately after my MSc. That's the first job I got. So that also was a big story in my college because somebody studied in that small college in a small village, got a job in TFR. It's supposed to be the best research institution in the country.
Yes.
It seems that my teacher celebrated that one of my students. So at TFR I joined. I wanted to do PhD, then I could not really join, and so I opted for a job there. So I was doing a 2 years. 2 years I was in the infrared astronomy group. I was looking at the stars and galaxies in terms of calculations, and I was a supporting team. So I was not a full faculty kind of thing. Just I had only a MSc degree. Then came my job in IMD. I was not very happy in Bombay because Bombay life was very terrible. And I'm from a village, then accustoming to a big city like Bombay. Then I had a lot of problem in accommodation. So I had a lot of difficulties. So I really wanted to move out. So then I saw this vacancy in IMD. So I wrote exam through UPSC. So I was a national all India topper. So I was selected in IMD. We had 10 people were selected out of a big batch. So I joined IMD. So when I was in IMD, I did my PhD.
So IMD, just to explain to viewers who might not know, it's the Indian Meteorological
Department in Pune. So when I was in IMD Pune is a research institution of recognized by Pune University. So anybody working there can do PhD. So I did not have a full-time PhD program in any university.
So then you did part-time registration in Savitribai Phule University.
The part-time PhD. Not a full-time.
And how long did that take you?
It took I finished in almost 4 years. I finished
very
very quickly did.
So what did you start working on in the
Initially, I was working on tropical cyclones and little bit on climate change programs. So for some aerosols, how the aerosols will affect climate. My PhD was on aerosols, how the aerosols can, anthropogenic aerosols, sulfate aerosol for example, how it can affect the climate. So I did a lot of modeling. So I was sent for a training program in the University of Illinois under UN fellowship program. So I was there about 4 or 5 months. So they gave me a lot of inputs. They gave me their model. So I brought the model. So I worked with that model, tried to calculate how much is the radiative forcing of aerosols. So that was my PhD problem. Then in 1994, monsoon, IMD issues monsoon seasonal forecast every year. 94 monsoon forecast was very poor, very absurdly, it was wrong. They issued a forecast of 92 or something. Actually, it was 110 or so. It's almost 18% out.
Okay.
So then I was asked by the Director General of IMD, Dr. Sendra, I still remember, they said, you go and help them. So I was pushed into that seasonal monsoon group. That's where I started chasing monsoon.
And when did you join IMD?
86.
86. So this is 6 years after.
87.
So 5, 6 years
No, sorry, not 87, 86. So almost after 7, 8 years,
7, 8
I was
years
asked.
after.
Still then I was working on tropical cyclone, weather forecasting.
And
Then-
what kind of work was it in those days?
Forecasting.
It was pen and paper calculation because yours were physical calculations or numerical.
So that at that time there was, the early days they used to issue forecasts using called synoptic charts.
Huh.
So we prepared all the observations we collect and put it in a weather chart and see where are these low pressure system, high pressure system. Then once you identify weather system, then you can issue a forecast assuming that this will move this side, that side.
But there were
So
no
it's a little more,
computers.
at that time it was not.
Huh.
86
So you
it was
would get large sheets.
large sheet, big charts.
Okay.
And then
And divide the country into grids and put
divided
the-
into grids, and then they plot all the stations data.
Okay.
So we have codes, different codes. So all the observations like pressure, temperature, humidity, wind, clouds, different kinds of clouds, what's the visibility, etc. What is the present weather, etc. They will plot each station in a coded form. The person who knows the meteorology will understand what is that. Then we used to analyze the pressure chart separately, temperature
So I have a
chart.
question then for you because I started remote sensing again in I'll say 93, 94, and that was the time we were moving from visual to the digital. So I think I was last of that generation who used the large maps and the digital things,
Yes,
and then we moved to completely digital products.
Yes. This also was 86 and all we never
computer.
heard about computer.
Exactly.
So
So I feel that because of that early exposure to something visual, drawing charts, my knowledge in some sense is more grounded because you understand things. Do you feel the same?
Exactly. I also learned a lot by drawing lines, ISO lines, and identify where is the low pressure system, where is the weather system. And next day you will see where it is which has moved. And also association with whatever you learn, physics, the physics of meteorology, weather science. Then you can really apply where it has gone, pressure changes, P24 changes, equation, mass conservation, everything you can apply in real time. When you use a computer, you are not able to appreciate what exactly is happening behind the computer. But when you are analyzing, you are really on the weather chart, isn't it? So,
Exactly.
so I learned a lot, I'll frankly speak. Unfortunately, that custom of analyzing weather chart has been stopped in IMD. They believe more in computer. Of course, computer outputs are required.
Very useful.
Very useful. Of course, they are powerful. It's no doubt. Weather forecast by using now mathematical models it's required. But
It's a
also you
different
should
way of
know you should also know the basics of. If you really start analyzing charts, it's good.
Yeah, I was looking at because my daughter is now in the 11th and she's doing a lot of integration, differentiation. For them, they do it on the calculator. Nowadays, you can get the input, the function, get out the output. And I wonder how that changes the brain because when you start doing those things, of course, it's very difficult to do it in pen and paper. And it's very powerful to do it. But when you begin by doing it computationally, what do you lose in terms of a certain mental capacity?
Exactly.
So
That is true. I think your mind will not grow really, especially logical thinking. Logical thinking you will not.
you will not. And a certain intuitive sense.
So it will move. And our forecasts, even those with those charts, at least have 24 or 48 hours forecast is to be good. So we know where it will happen. And you need a kind of basic knowledge of climatology of that particular place. So your knowledge will be applied to that analyzing charts and try to interpret it. Now those things are stopped. Now we completely moved to so-called numerical weather prediction, where you use computers, you use mathematical models, and then we see the output. Then output we interpret and give the forecast. That's the way we do now.
So to return to your the incident you were telling me, you said 94 the prediction.
94 the monsoon forecast was very bad. And so they wanted to augment that group, monsoon forecast. So monsoon forecast was one of the highest landmarks of IMD. So IMD is known for monsoon forecast because we started in 1886. So, and government also wants that forecast.
1886?
1886 was the first forecast issued. Yeah. 1886 by then the British government.
Okay.
So they knew the importance of monsoon at that time. So they had a lot of droughts, famines and all at that time. So they thought that you should know about monsoon. So then they brought this their so-called seasonal forecasting scheme. From there we moved on. And when I was there, so we used to use statistical methods for calculating how much rainfall will come and also. But the model was not so good. So I was asked to help them to improve the forecast and all. So that was the beginning of my monsoon. So then of course I knew the basics of monsoon, but I never chased the monsoon every year. So that was an opportunity where I should know what is happening in the monsoon every year, when it comes, when it goes, how during the season, how it happens. Well, ultimately it will affect my forecast, isn't it? And so I started really learning more about monsoon by seeing weather charts, computer outputs, etc. So,
and South Asian monsoon is notoriously difficult to...
Notoriously, among all monsoon regions, South Asian monsoon is most difficult to predict.
Why is that?
There are a lot of problems in terms of its basic structure, the physiological structure, like there's a mountain Himalaya, there's the ocean, there's the west coast, the Western Ghats, so an interaction between land and atmosphere. It's a much more complex physics than anything else. So that is one of the reasons that we don't do well in monsoon prediction in South Asia.
And in 94, when you started engaging, what was the resolution, spatial resolution?
At that time, it was statistical model. We never used a mathematical model, even 94.
So statistical as in you would interpolate between the previous year
and
the
next?
next?
What we use is an equation. So in that left hand side is the rainfall, what need to be predicted. Right hand side is some parameters. Okay. So y is equal to a1 x1 plus a2 x2, that kind of equation. But it was non-linear. It's not a linear model. It's non-linear model. These are we call predictors.
And what were the predictors?
Predictors are like a sea surface temperature over Pacific, wind over Indian Ocean, that kind of thing.
That kind of thing.
So which we feel that these are the parameters which affect monsoon variability.
And what did you, when you came in to fix it, what were the first things that you felt you could?
I told, so I'm opening up. I told this model is not good, and because statistically the model cannot be really fitted into that equation. We used the model has 16 parameters in the output, as a predictors, and 16 then power is so 32 unknowns, and we used only 30 years of data to fit that equation.
Over-determined.
Over-determined, so it's overfitting. You cannot do. You'll get a good results at least on paper, but when you really start doing it on real time, you will fail. So I told it's basically wrong. It's fundamentally wrong. But I'll tell you, the model was developed by the people like Gaurikar, Vasant Gaurikar and team. You cannot challenge.
Right.
You cannot challenge. You can only question, you cannot challenge. So in spite of me saying that this model is not good, they persisted with that model. In 2002, the utterly failed. It was a big drought. And then the forecast failed. Then I remember then the Dr. Kelkar, who was then DG, asked Sulojana Gadgil, she was in IAC, they asked her to conduct a brainstorm meeting. I remember I went and gave 2 presentations. So there we took a decision, we had to change the model. So then Kelkar, I remember that when we were taking dinner, Kelkar came to me saying that, Rajeevan, you please change the model. I was given freedom. Still, we could not do it completely by 4 years. So the new model which is now existing in IMD's forecasting tool came out only in 2007. But 2007, that model which we developed indigenously with our own group, I don't claim that it is my model, it's our model. But then that model was it's much different than any statistical model. The state-of-art statistical model. Nobody will say that you are fundamentally wrong. Forecast still may go wrong. But they won't tell you are wrong. You are in mathematical formulation, you are wrong.
Correct.
So you should be good in formulating the model. Whether it fails or passes is
because it's so complex, it's difficult.
It's so complex. So then that model is still existing.
So what is the difference between that model and...
The model, first of all, they use so many predictors. We should not use so many predictors. It's not necessary. So in our model, we use only some 4 or 5 predictors.
Okay.
And
And then you also spent a lot of time looking at how to downscale, especially downscale. And now we have 12 by 12 kilometers.
So that's a mathematical model.
Ah.
So the mathematical models are now, it's called general circulation model. It's called NWP
So
model.
if readers are, for
So
listeners,
numerical weather prediction models are, of course, I'll talk in this my presentation today. So basically, it's a mathematical model. We solve some 7 equations. So conservation of mass, momentum, energy. So this kind of the heterostatic equation, etc. We solve it using mathematical equation, mathematical
approaches,
algorithm. And further, you need a huge computer. Huge computer. These are non-linear equations, so they don't have analytical solutions. So we need to do as a kind of approximations. So then you do either finite difference method or spectral method we follow. Then you use a big computers to do it. If the resolution of the model is so good, 12 kilometer, then you need a bigger computer. Earlier the model resolution was about 80 kilometer. What started with 180 kilometer, then we went to 80 kilometer, then 24 kilometer. Now we have 12 kilometer. The next year I think we are going to 5 kilometer model.
When did we start the 12 kilometer?
2017 when I was secretary.
10 years. Okay. At that time you pushed it. So with that kind of an evolution, you also then, when did you move to the ministry?
Ministry, I joined ministry in 2015, December. As secretary. I was director of IITM at that time, IITM, Indian Institute of Tropical Meteorology, Pune.
So can you first tell us, so when did you move to IIT?
So I moved to the whole country. Till 2008, I was in IMD Pune.
Okay.
In 2008, I was hired by ISRO. ISRO by Dr. Madhavan Nair Rajeevan, then he was chairman. He wanted to develop a modeling group in ISRO to help the rocket launches. For rocket launch, they need very precise weather forecast.
I didn't know that.
Oh my God! Without weather forecast, they cannot launch.
Okay.
They're also very precise.
Okay.
When the rocket goes up, they should not have a wind, cross wind, so that it will come and hit the pad. And also when it goes, it should not drifted from the track which are supposed to go. So it is fired in a particular track. So if the cross winds are there, it can go like this.
Oh, I did. Makes complete sense, but I never thought about it. Oh my God,
it's a very, very precise forecast. Then also thunderstorms. It's full of electronics. The rocket is kept in the so-called launching pad almost 3 days, 4 days before. Then they will do all testing. During that period, if a thunderstorm comes or lightning comes, if it is not known, the whole machinery in electronics can get shocked. So it can get short circuit. The whole thing will go back. So we should inform them in advance that a thunderstorm is coming. So that what they will do, they will switch off the computer, machine.
So how did he get this job? He knew and he hired you, or you applied
he
for a
knew
job?
me from IMDs through some people.
Okay.
And so I was hired for a job. So then I developed a modeling group in. I was in Tirupati, a place called Tirupati. So I was in the lab in there, ISRO lab. So I hired few people from different places. I took one girl from IMD, and so who helped me to develop that gridded data set, Jyoti Bhatte. So I took her. So and also I brought somebody from CDAC. So we developed a small team. Still that modeling team is still there, and they help ISRO to make a forecast. Then 2012, I was asked
If I could just ask you, how was that experience working with ISRO versus
it was good. It was so good. It was so good. I used to go for these rocket launches. So we used to go there and stay there about almost 1 week before. Then give everyday forecast. I'll tell you a good story. 2008, when during the year I joined somewhere in July, and October was the first Chandrayaan launch. So they make a team. So I was the leader of the team. So my job is to give forecast and briefing to the launching team. They have to take a decision. It's called Launch Authorization Board, Launch Authorization Board. It's a big team. They take the decision whether it is to be launched, when it is to be launched, etc. So I was asked to give a forecast. That is the period your northeast monsoon onset. Heavily raining. Heavily raining. It was somewhere, I don't know the date, but it was almost 10 days before the rain started. All people started worrying. So much heavy rain and thunderstorms. Oh, huge thunderstorms. Every day they will get 2-3 thunderstorms. All people are worried. I gave a forecast saying that, I'm not saying that I'm exaggerating. I told the chairman, Madhavan Nair sir was there, sir, if you assume that your rocket can withstand rains, please go ahead. Okay. He said that rocket is rain-proof. Even rain is there, it don't affect. We are worried about thunderstorm. I told sir, activity will stop in another 2 days. During your launch time, there will be no thunderstorm activity. Is are you sure? I said, yes, sir. Then all our remaining people are asking him to please, we'll postpone this launch.
Huh.
It was a big mission, Chandrayaan mission.
Correct.
Well, he said that's nothing, we'll move. He took a decision to go on. Frankly speaking, the thunderstorm activity stopped after 2 days.
How did you know that?
Very good. It's very simple logic.
Huh.
Thunderstorm activity is because of heating. The land temperature
Excess
heating.
heating.
It's excess heating. So much will go up, and once it starts raining, the surface will cool. There will be no further convection.
Which is why, because you're a physicist.
I am a physicist. Exactly, I am a physicist.
Ah.
I use my physics knowledge and also the local climatology knowledge, and I told that it will not be rain, thunderstorm activity. They are very happy. And during also it was the early morning launch. I told when it was raining. Rain was there. But I told when your rocket launch is happening, there will not be much rain. There will not be much rain. All these 3-4 hours it will not rain. When it was raining till the midnight, when the rocket was launched, there was no rain.
And again, how did you know that?
It's a diurnal variation.
Okay.
Because it doesn't rain all 24 hours. It rains in a
Correct.
few hours. So that particular station, Sriharikota, has a peculiar thing. Early morning doesn't rain.
Okay.
Okay. Again, physics, understanding the physics.
Right.
So
Like Bangalore usually doesn't rain in the night. I mean, there'll be a period between 4:30
yes,
and 7, 8.
yes. Exactly, everywhere. So if you know this kind of climatological knowledge, you can use it for. You don't need a model to predict, isn't it? It's all your local, your internal. What do you know about the climatology? So that I use. So I became big hero in ISRO in a few months. So then 2012 I moved to ministry again as a advisor. So that is Dr. Sailesh Naik was the DG, secretary. He wanted me to go. And at that time they launched the Monsoon mission. So to improve the monsoon forecast, he wanted me to take care of the Monsoon mission in the ministry. In 2015, when this advertisement came for IITM, I applied. So I was selected for IITM director. So I moved in March there. Then 2015 December, I was there about 8 months or 9 months. I was hired as a secretary here. I moved here.
So when you moved from ISRO to ministry, what was the difference in, again, ministry to IIT?
ISRO is I'll tell you, it's a fantastic institution, beautiful institution. I learned a lot from them. So first of all, it's teamwork. Teamwork. You have to work in a team. And you may have differences, etc. So, but once you, for example, in the discussion meeting, you may have firing people like anything. There will be hundreds of different opinions. There will be hot discussion. Then they take a final decision. We will do this. Once you come out of the room, that's the end of it. Further, no question. They will work only on that. Whether it fails or not. So then again, they will not wonder, oh, we should not have taken this decision. Nothing. They will go ahead. And rocket launch it involves many people. You need satellite people who made a satellite. The VSSC Trivandrum is making the rocket, and communication is done by somebody else. And shore people will put all these fuel. They are the responsible people to send the rocket up. So it's a different kind of team. But when they come, they will all work together. No difference. That's one thing I learned from them. The second thing is asking questions. There they have even courage. Youngsters have courage asking even questioning chairman. Chairman says something. A young person can get up and say, sorry sir, this cannot be done. This may not be true. That kind of freedom to express views and kind of a lively discussion. So that is there in ISRO. That's why ISRO is doing extremely well. So they have that capability. They want good science to happen. Ministry is ministry, not very tough questions. You have to somehow manage it, that kind of situation. I can't blame them. That's the way ministries are run. Not very serious questions to anybody. So if they say that you do this, that's all. But in ISRO, it's not so. They will ask hundreds of questions, why we want to do, why we should do it, we cannot do this way. Ministry was so. My biggest advantage was I was able to accommodate or adjust myself to all this environment.
Exactly. So
that's why I worked in different environment. IMD it's a good organization, but I had hundreds of problems. You cannot publish paper outside. They have a journal called Monsoon, so you have to apply only you have to send the paper only to Monsoon. You are not allowed to travel. You are not allowed to go to a conference. So many hardships I had, but still I managed to do well. I mean, ISRO was still better. Then I went to ministry. Then IITM was a good institution where I spent only a few months there. Then I moved to
there. But in the ministry, then you would have had many more opportunities to influence policy and to engage with policy.
Becoming a secretary is a really big advantage.
Right.
So, first of all, I am very happy that I became secretary. Second thing, I could do many things in the secretary. So, secretary is a very powerful post where you have a lot of freedom in the sense you can do good science and you are given a lot of money and also you can design what you really want. So, frankly speaking, 6 years I was there, almost 6 years. I could contribute a lot to the country.
Right.
Country's improvement, especially weather and climate and earth sciences, including ocean, seismology, polar science. It's very powerful post. If you go and talk to the PM office saying that I want to do this, they listen and they allow you to do. Okay, so it's a really good position where you can really contribute to national activities.
So, what are some of the initiatives you got done?
So, one is the weather and climate sciences. So, we could bring a lot of good science. I concentrate more on science, improving science.
Yes.
That is very important. Unless you improve science, your prediction will not happen.
Yes.
So, I emphasized on doing research, development of models, etc. So, many new models, the models which are being used in IMD and MOES is all brought in during my tenure. I told you should develop this, you should develop this. For example, there was no prediction system for thunderstorms. I remember when 2019, Bihar, 200 people died one day simply because of lightning. So one day, it was a huge thunderstorm activity. People are all on the field. 200 people died in one day. It's not really good. So then PM office also was very annoyed and they also got upset. So then I developed a prediction system for thunderstorms now. So that is being operational now. And there is a lot of air pollution in Delhi. It's very famous. And so they wanted to develop a air pollution warning system in Delhi.
Okay.
PM office is written to Ministry of Environment and Forest. They told you please develop it. So I got it developed.
Okay.
So we have now a prediction system for Delhi. Okay, but we took help from National Center for Advanced Research from US. They helped us.
NCR.
NCR. But we did a good job. So now the system is there.
Okay.
Like that, we did a lot of good things. And also fog. Fog is a very big thing in... so we did an experiment called the fog experiment in Delhi. IFX we call. So we did a series of experiments every year during fog season to put a lot of instruments, try to understand how the fog really develops, why the fog is happening.
These are all very complex phenomena.
Very complex phenomena. Fog is very complex phenomena. Air pollution is very complex phenomena. It's not a simple physics. Of course, it's all in all physics, but there's a lot of non-linearities. For example, fog, it depends on humidity, it depends on the wind, and depends on the surface conditions.
And a lot of what they call the butterfly effect.
Butterfly, right? All these things.
Some small changes in the initial conditions.
So fog was really. We did. So I liked it. I did a lot of improvement in weather services, weather and climate services.
And so, what would you then advise me for younger scientists listening to this? Because one of the things I think, when we were discussing this briefly, weather, climate, ecology, broadly, all of these areas where a lot of very good science happens in India, no doubt. But I see that many scientists stay in their science zone. It is changing. But there are very few, especially I think of earlier generations that I would know who have moved across these fields. Not that there aren't, but there are few who have done science engagement with policy, science engagement with communication, science engagement with the real world really. Many scientists tend to very naturally, that's how we are trained. We are trained that you're supposed to be in a scientific organization, publish research papers, get a good H index, get your tenure, publish, go to conferences, but needs to do much more, especially in these areas.
Much more. So I was very emphatic on the sense that you should really talk to the people, give your views to the people, and also influence the policy makers, what science can do for you. So when I was secretary, it was a wonderful opportunity for me to talk to the top people in the bureaucracy and tell them, sorry, this is the thing, you should do it. And I used to go and help them, and the helpers said that there are issues. Whenever issues come, I go and help them, and they are very happy with that. So I could influence the societal issues to be resolved, or to solve the societal issues. It was a wonderful experience in that way.
So it's not many people I find when I talk about these things, they say, oh, it is a very risky thing to do. Your career will suffer. But actually, your career is not far from suffered.
Actually, that's true. I had a tough career, but then I enjoyed it, and frankly speaking, I feel I'm a successful career I had.
Much more than, in fact, in that sense, you are known for much more, or you have achieved much more and left a footprint which is more than a set of papers.
Yes, but for example, if I retired only as a scientist, I could have happy that, oh, I published so many papers, I have this H index. But now I am very happy that I could really contribute a lot of things, much more research papers for the country.
For the country. And you still have a very good publication record.
Yes.
I think that is the sort of the thing that I find interesting.
Yes.
Because people think it affects your science. It doesn't. It adds science plus something
Yes, I kept both the things intact. So I used to, even when I was secretary, I had 2 research PhD students. I graded 2 PhD students. And I still write.
That's how you managed it.
I used to interact with all my old colleagues. Research was my passion. So even when I go home, I sometimes write papers, etc. So research was my passion. Even when I was secretary, I was fully active. I could have stopped it. I could have easily stopped it, saying that I become secretary. No, I cannot do. But I did not do it. So that is there. The second thing which I could do it is the launching of Deep Ocean Mission.
A Deep Ocean Mission.
Deep Ocean Mission. It was a beautiful project which was launched. It's about 4,700 crore project. So that we took about 3 years to convince the government, saying that activities related to ocean deep ocean is very important. Like a space which was there, like a strategic issue in 40 years back, ocean is now very strategic because a lot of wealth is there. There's a blue economy. People are talking blue economy. If you go down, you can get a lot of money out of that. But there are a lot of restrictions. So we need to really invest. This is the right time that we invest in blue economy and also do a lot of activities.
Geopolitically very
important. For example, ISRO is talking about taking a person out, 3 people out. So we are thinking of taking 3 people down. So up to 6,000 meter.
Okay.
So we are 6,000 meter. The ocean is up 6,000 meter. Indian region where we have some contract with the UN saying that this is the area where you can explore for minerals, cobalt, nickel, cobalt, etc., magnesium. But that technology is not readily available. Only some 4 countries have that technology. It's called manned submersible. You can go down. You can spend about 3-4 hours and so maybe maximum 5 hours and come back. I went to Japan. They had this technology. I went to US, Woods Hole Institute. They are not ready to share any. So because it has become very strategic.
Okay.
They don't want to give. So we are developing ourselves now. So MOS institution, NIUT Chennai is developing themselves. So they are planning another 2-3 years. They may launch it.
So you have the satisfaction of starting all of this.
I am very happy that I could launch it. I had a lot of trouble. So I'll tell you one important thing. Our budget is, the ministry budget was 2,500 crore during that period. This project is 4,700, more than double of our annual budget. Do you think anybody will get convinced that you can do this kind of project? ISRO get a lot of projects, but their budget is 12,000 crore. Out of that, they get a project of 800 crore, 1,000 crore. They're sending, Mars going, 1,000 crore, fine. But the total budget is 12,000. But here it is just reverse. We have 2,500 crore to run the ministry. Then you are asking for a project of mission of 4,000.
And that's one project.
One project. I could convince. But finally, I think PM got the thing. Prime Minister got the feeling that no, this is important. He pushed it. So
and then we can be leaders in that field.
Yes, we can be the leader. We should not, if you are staying back saying that it's not possible, it involves money, we always will stay back. So person who takes first step always will move forward.
I mean, if you think of how ISRO was set up, that is how it was set up then. People were saying that India is a developing country. Should we be doing even things like this?
Exactly. And also there was a lot of sanction because of nuclear energy policy. There were a lot of sanction. Nobody was willing to even share a small electronic instrument. Then we did it ourselves.
Exactly.
We did it. So we should do that.
We should invest. Okay, so I have one more question then, because this is the current stage of your career. Once you retired from the ministry, you moved to Atria.
Yeah, 2 years I was in MOS institution in Trivandrum as a MOS distinguished scientist. So that is a period I wrote that Monsoon book.
The one that is just released?
That's Monsoon book.
Okay, that is when
So I told her, you give me that position so I can go there and sit there and do. Sitting at home, you cannot do this kind of thing.
Correct.
You need a lot of time to invest. So Secretary Ravichandran was very happy to give me that position. I spent 2 years. By that time, when book was almost ready, then these people. Yet University offered me this position. I moved in. So I cannot sit at home. In the sense that I have to do something. So sitting at home, I cannot do it.
What do you think is needed for the future career of students? If let's say you had no obstacles, I mean, money was not an obstacle, no practical obstacles, and you could just dream big. What does India need and what does the world need in terms of young people who are trained in climate and weather, what should they learn? How should they, what should they do? What are the careers we need?
So in weather and climate sciences, we need, see, weather and climate science is very important for any country, irrespective of how big your country is. For example, improving weather. Now, see, in future climate change, we are expecting a lot of more frequent extreme weather events. So we need to predict them. So our disaster management system should improve. We should have a better early warning systems. For that, you need a huge human resources, people who can do really the good job. And these are all interdisciplinary.
Yes.
A physics student may not be able to do it. The team should have students from maths, computer science, electronics, people who are good in IoT, people who are doing AML. So all these things are required. So that kind of a field. Regarding climate change, we know that climate change is happening. Global warming is happening. We are seeing the impacts of climate change everywhere in the parts of the country, and it is going to increase further.
Exactly.
It will aggravate further. So we need people who can really make policies, who can really guide the government to understand what kind of mitigation and adaptation issues we need to resolve. And so for that, it all should be evidence-based. Somebody is saying that, no, sir, we should do this. Government cannot do this. Government needs data.
Correct.
Kind of information, learned information saying that if you do this following this way, then you can have this kind of thing.
Exactly.
So for that, you need people who are good in science, try to understand what could be the impact and what could be the pathways. There can be hundreds of pathways. What should be the best pathway you can choose for the country to have mitigation? So India is a growing country, developing country. So we can easily stop coal. We can stop. But it will impact millions of people in the country. You cannot simply do it in overnight. Okay. We are moving to renewable energy. So then also we need development in many places. So you need to have policies on sustainable development. And when you start doing it, there could be a lot of impacts on other sectors. So it's a huge problem to be resolved. So for that, only government cannot really do. So
do we have enough education in these areas? Higher education?
No. I'm sorry, it is not there. It's not happening. I heard that you are trying to do it.
We are starting an MSc program.
It's good. Really, I should really congratulate. We need to do that because simply learning the science of climate change will not help. Now we are too good in science of climate change. It's not, for example, IIT has a climate model. We are writing so many papers. This will happen, that will happen. So what? So what? Private should ask, so what?
Yeah.
What I should do? So you should tell the people that these are the pathways you can do it. Mitigation is a little tricky issue, so you need a lot of thinking but adaptation you can do.
We need a lot more work.
A lot of work to do. That also everything should be science-based or technology-based adaptation policies.
And unfortunately, we need thousands of students every year, and what we have is maybe hundreds of students, in the low hundreds across the country.
Not even 100 per year. When we recruit, when I was there in ministry, I was trying to recruit people. We don't have people, good people. I'm talking about good people.
Yeah.
Of course, people are there, but good people who can really, if you give a job, they will do independently.
Right.
Independent. I'm talking about independent researcher who can think and do it ourselves. Otherwise, if somebody guides, anybody can do. Okay.
Because you have only, agreed.
Very few.
And people who take ownership and run with something.
Very few people.
Yeah.
We need such kind of people.
Recently we started a webinar series called Let's Talk, where are the jobs in climate change, and we thought it only young people would join. But we are finding people, someone said, I've spent 30 years in finance. Someone else said, I've been an architect for 20 years. They all want to make a difference. They have done something in their careers, but they feel this is the crisis of the next few years.
It's a crisis for the next few years.
And they should somehow
not only for the country, the whole world.
The whole world.
So we need to really start doing a lot of serious activities in terms of awareness, in terms of the basic problem is funding. You need money. Adaptation, you can simply talk. Then if you really want to develop a technology, you need money. It's huge investment. That's why when we go for these co-op meetings and all, we talk, you burn a lot of fossil fuel. At least you give us some money to adapt ourselves.
Correct.
Isn't it? So
the loss and damage fund, all of those are very
exactly. That came because we need money. It's a huge investment. For example, carbon capture.
Yes.
It's a good word. But if you really want to implement, you need huge money, carbon capture.
Exactly. So it's so much more expensive to have cement with carbon capture and so many other things.
You can always talk. These are all. So they will summon in the boardroom and talk about things, saying make a PowerPoint presentation and go. But if you really start doing, you need money, you need people.
And long-term investment.
Long-term investment. It's not one day money. No. It's a huge investment over the many years. So who will do it? So government is really, my point is that government is really doing well, but they have a lot of constraints. A lot of constraints.
They cannot do it alone.
They cannot do it alone.
Yeah.
Industry should come.
Industry should come.
Corporate should come.
Which means we as scientists should not only engage with policy but also with industry as
Exactly,
much as we can.
exactly. That is not happening. So, for example, academia-industry relationship is very poor in this country.
Very poor.
We don't go to industry. Industry don't come to us. For example, in US, weather and climate service. For example, NGOR. The weather and climate models are developed by universities and the big corporates fund it. For example, Google they fund, IBM they fund a lot of money. They give a lot of money for research, for weather and climate. So industry partnership is very high in US, but it's not happening here. If you go and talk to them, they say that what I will get. You go and ask them, can you fund some 10 crore for this project? I will give you, but then what I will get? Whether I will get 15 crore, I will give you.
And next year,
then I will give you 10 crore. That's not going to happen. So the so-called CSR funds are all there on paper, but really it's not happening. Frankly speaking, it's very unfortunate. It's not happening. We simply talk about CSR funds. University also, sometimes we say, why can't you ask some industry people to share some money from CSR?
A lot of work has to be done in starting conversations. I think these conversations have to continue.
So government can take a lead bringing people together. So I am very happy in the new institution called National Research Foundation, ANR.
Yeah.
So there the emphasis is on bringing industry to the board. So for example, if you write a proposal of 100 crore or 10 crore, 7 crore should come from industry. Government will give only 3 crore to you. So then you will go and talk to industry and tell them that you give me 7 crore, then we will do this project. It's good.
It's good, but it will be hard.
It's very good. It's a really exciting move, but it will happen.
Something has to happen to bring people to the table.
Yes.
Then the conversations can take.
So that is a new idea, but then its implementation, I'm not saying it cannot be implemented, but it is hard to implement. So then we need to really work hard so that it is implemented. So that's a thing.
So I've got two last questions for you as we wind up. One is, I know you are a grandparent, you said, for a 6-year-old boy.
Yes.
What are your hopes for his future it's a fast changing world. What are the hopes and fears?
He's in US, so he's a US citizen, so he's taken care by the country, but then he should have an ambition, and I wish that he should do well, whatever he do. See, when I was growing, my father and mother did not have any clue that what I will become. Even I myself, I did not have any clue I should become a doctor or lawyer. I did not have any clue. Only for my son also, only thing he should do well. He should be a good human being. He should love nature. He is showing already a lot of interest when he wants to go to park every day. When he goes to a park, he goes and hug the tree. I don't know whether it's a naturally is coming, I'm not sure. But I am happy to see that.
Very nice.
I am happy to see that he is going and hugging trees. So you have to be part of the nature and do well. That's all. Whatever he can do, he should do well. I wish that, I am very sure that he will do very well in his life.
Very nice. And the last question is, for young people watching this, what do you have as, let's say, one piece of advice to do and one piece of advice not to do?
For young researchers.
Young researchers.
Only hard work. There's no doubt. You cannot do anything without hard work. You do hard work. I became whatever I am now only because of my hard work. If I stay back and saying that everything will come on my table, you cannot do. So be sincere. Do your part. See, life is not very simple. There's a lot of hardship comes. So, but then you have a kind of ambition. Keep working on that. So you should not get. Once you get a full step further, then you don't get back. So keep moving with a very, very big mind to work hard. The second thing is be honest to you. That's more important. Honesty is very important.
Very true.
We hardly find people with honesty.
Honesty to yourself. What happens is, I think often people tell you, especially, and they have a way of mocking younger people when you're very idealistic. It's okay, it will go in time. But I don't think so. I think we should keep our idealism.
Yes, we should keep our idealism. I am very, very firm in my principles. I have some principles. I never deviate. I never deviated. You know how difficult to be a secretary?
I'm sure.
Made a lot of pressure on me, saying, you do this, you do that, why can't you help this? I had guts to, I'm frankly opening up, I had a guts to say no to politicians. very hardly many people, no one will
Not
do.
easy, not
I think
easy.
not easy to do. But I had a guts. So because I am very firm that but I know this is wrong. I will not be doing that wrong. Whatever comes.
Wonderful, wonderful to hear that. I think that actually, I said it was the last question, but I think I'll ask one more. What are your plans for the next future? As you said, you cannot sit at home. So let's say in the next 10, 20, 30 years, how much of a working life?
I don't know. I'm not sure. But the university, I'll be staying back for 5 more years till they say that I don't want you. Till then, I will be here. But then I am really, frankly speaking, I'm thinking of writing another book.
Wonderful. I thought so. I was just going to ask you.
I'll tell you the background. I'll tell you the background. It's my ambition. So hopefully it will happen. Is the book which I written is basically meant for a postgraduate student or early career research. It's a little advanced, but not very tough to read, but little advanced for. I want to write a popular book on monsoon.
Oh, wonderful.
Monsoon is a part of our life. Without monsoon, we cannot live. We cannot even think about it. Monsoon is a part of our life, day-to-day life. I should write a book on monsoon, which is very basic. Anybody can read. It can be easily translated into different Indian languages.
Wonderful.
Different languages. I want to really chase monsoon for 1 year. I will start from Trivandrum. There's a book on, I forgot his name, Monsoon, Chasing Monsoon. It's a very old book. I forgot his name. So that book, the author goes to Trivandrum and chases monsoon till it goes to Delhi. And wherever he goes, he picks up some conversation and what do you feel about monsoon. I want to do the similar kind of story.
What a beautiful idea.
So then you will describe science in a simple language for some onset. What do you mean by monsoon onset? Why it happens? And that science you talk, but in a simple language, not with the equations, complication. Then you talk to a person who is in Trivandrum and say that how you feel about onset. Talk to a fisherman who goes to the sea and come back and he said that what do you feel about monsoon onset? How you feel it, and what is your experience of monsoon onset every year? So then kind of a societal linkage with that what I write. So similarly, when you become a break monsoon, every year there will be no rain. You talk about how break occurs, how a break event happens, physics of break event. Then you go to the village and ask, what do you feel about this break? When monsoon is now, rainfall is there, how you feel? Farmer, for example. During this period, what do you expect? What you will do? Do you want this kind of forecast for breaks, that kind of? So a kind of linkage. So this is my dream. Hopefully it will happen.
I think this sounds wonderful. I look forward to it, and we would love to have you back to discuss the book.
Yes. Hopefully. Thank you very much.
Thank you, Professor
Harini.
Rajeevan. Such a pleasure to talk to you.
Thank you.